Hi, I'm Andrew Pujanowski, and I'm going to talk about the program um, that will introduce students to structure-based molecular modeling. And this is going to be based on my experience of 30 years in, actually drug discovery um, research, and more specifically in computer-assisted drug design. And um, maybe a little bit about myself first. Um, Prior to those 30 years at Bristol Myers Squibb, I got a bachelor's degree in chemistry at the University of Illinois at Chicago. And I went on and got a master's and a PhD in physical chemistry, also at the University of Illinois at Chicago. And then I went on and did postdoctoral research at Stanford School of Medicine. And our group then moved to the Stanford Research Institute. And we were in the molecular theory group. And from there, I went to Squibb, which was way back in 1982. Um, Now, currently, I am based in Yardley, Pennsylvania, which is uh, northwest of Philadelphia and is just across the river from Trenton, New Jersey. Um, Structure-based molecular modeling is a very important methodology and technique which is used in discovering new drugs. And it's based on working from protein structures. And so we're going to build up in about a week's time, we're going to cover the structural aspects of chemistry, which the structural chemistry is an extremely important area of chemistry, kind of underlies everything else. Um, I'm going to cover it from the standpoint of AP chemistry, and there's a structure of matter component in AP chemistry, which I think is going to be sufficient to go all the way into structure-based modeling. And it will be challenging for me as well, but it doesn't really require any additional knowledge of, say, organic chemistry, where you have to memorize tons of equations, not equations, but reactions and reaction mechanisms and syntheses and stuff like that. This is more to do with organic chemistry nomenclature, and with geometry, there's no advanced mathematics involved, and that's why I think that motivated students who have had exposure to AP chemistry will do, I think, well, um, as long as they are prepared to be challenged. So um, I'll let me display, like, this is kind of where the structural chemistry part of it ends up. This is a program that we'll use called Avogadro, which is a molecular display program. And this is a display of a very familiar organic compound called caffeine. And so we'll cover all of the structural elements that lead up to working with compounds like this. And caffeine is kind of typical of what drug molecules look like. Um, so this is kind of where the structural chemistry part of it will end up. Then we will go on to talk about proteins and amino acids, and I'll show here a display from a program that's called PyMol, which we're also going to be interested in using. And there are a couple of things going on here. This is the MCL protein, which is being displayed as in helical form, and we'll get into all of that. We'll shut some of this off, and I'll kind of just go over very quickly what's involved in structure-based modeling. This is the protein here that we're trying to do something with, inhibit, whatever, and this is a molecule that is, it's called BIM for short, which is pretty complex, but this is found to inhibit the MCL protein, and the MCL protein is just one protein that's involved in certain forms of cancer. So this was an anti-cancer program, and this is one that we actually were involved with at BMS. So the way we handle these things is we get a structure for the protein, and we'll get into where these structures come from, and we represent it like this. We get the structure with something bound in the binding site, which would be this compound, this BIM, and then we look at a program. I use a program that I wrote, which looks for regions in the empty binding site. So these surfaces are regions which would be attractive to certain parts of molecules which are called hydrophobic, and we'll get into that as well. So this is mimicking what would happen if you put a methyl group in these various parts of the binding site. And as it turns out, you can see that there are certain parts of this molecule, the inhibitor molecule, that actually fit into those regions, and they have affinity for those regions, like here, 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 and so this is one way that we go about examining proteins and finding compounds that might act on these proteins. So that's essentially structure-based modeling. Once you find regions like this, then there are other programs that will go into a database of molecules which purportedly have activity, and will automatically try to put those molecules into the binding site that you're looking at, like this binding site here. And these are called docking programs, docking algorithms, and there are a couple of them, in particular AutoDock, which will start with a bunch of compounds and try to fit them in. And so this is a way that chemists, medicinal chemists, and people who work with them in computer-assisted drug design look for possible active drug candidates. And so this is a way, it'll be challenging. We'll do introductory work like this for about 3 weeks, and then we will go into a 4-week phase where students will pursue a research project involving proteins like this and structure-based modeling. And I'll be I wouldn't say tutoring, I'd say mentoring students as they do this research on a regular basis for those 4 weeks, and then of course I'll be available for any questions or problems that arise. And I see this as a way to uh, try to pass on some of the experience that I've gained, and I look at it as a challenge, but I also look forward to um, possibly helping people. I know this would be uh, a very, I think, useful program because it will help students who are interested in going on to chemistry or biochemistry or pre-med studies to really get a handle on structural chemistry and how things are actually done in drug discovery research. So it will be useful for students who are really motivated to try to understand um, these aspects of biological chemistry and structural chemistry. Um, so, yeah, I'm looking forward to it. Thank you.